Greetings ACT specialists, we're taking a look at how to balance reactions. So this is a problem you might remember from class, but it's okay, we'll review it. If not, you can try to do it by yourself, or even if you do remember doing this problem, try it again to make sure you got it. Alright, so but the key with balancing reactions is knowing where to start. I've got this huge molecule here, and it might be tempting to just start at the beginning with the C. But you'll notice I have 1, 2, 3 molecules with carbon atoms in it. And I know I need 16, so I could try to play this game where I'll say maybe this is 2, and maybe this is 5, and maybe this is 1, but that's really complicated. So I'm just going to skip my C's for now and come back to them. Now let's look at my H's. Well, I've got H in this molecule, H in this molecule, and H in this molecule. That's pretty tricky, right? So the simplest molecule element I could take a look at is probably S. So let's go for the S right away, because I know I only have one S here. So, well, where's the S? Here. Okay, so because I know I only have one S in my product, I know that this has to be 1. In other words, I can only have one of this molecule. So HSCN, I can only have one of them because there's my S, here's my S, so the S checks out. Alright, let's think about another one. I could go to O or N. Really doesn't matter, so I'll just work my way backwards to O. I look at O, I see CO, and I don't see any other molecules with O in it. That's really exciting because I know if I balance this one, I'm done. So I take a look, I see CO, I've got 5 C's here. I know each CO looks like this. Each CO molecule looks like this. And so that means I've only got 1 O so far. Well, I need 5 O's. So in order to do this, I'm going to need 4 more of this CO carbon monoxide molecule. And so my sketch is like that. And I need 5. 1, 2, 3, 4, 5. So I'm going to put a 5 here because I have 5 of these molecules. 5 COs. Great. My O's are done. Okay. Now let's work our way back to the N. I know I've got 2 N's. Out of the ones I already have done, I have 1 N. So that means I just need 1 more N somewhere. Oh, this molecule has just 1 N. So I could put a 1 in front of here. So that means I've got 1 N here, another N here. So let me do this, NH3. I've got 1 N here, 1 N here. That gives me 2 N. So between these 2 N's, I've added up to 2 N's. That's done. All right. Now let's go back to the ones that were difficult at first. I've got a choice between C and H. If I look at H, I know I need 18 H's, but I still have 2 molecules that could possibly have H's or hydrogen atoms contribute. So that's still a little bit tricky. If I look at C's, however, these are all done already, and I know, okay, this is the only molecule with C left, so I can start figuring out how many more C's I need. I've got 5 C's from this molecule, so I'm going to just jot that down. I've got 5 C's. In this molecule, there's 1 C, so I'm going to need to add 1 C. And that's it. So I've got 6 C's so far. I need 16, which means I already have 6. I need 16. I only need 10 more. Okay. Well, C5H5 in one molecule of that, I've got 5 C's. But I need 10 C's. So in other words, if I were to have 2 of these, that would give me 2 times 5, 10 C's, plus the 1 C from this, and the 5 C's from here, adding up to 16 C's. So that checks out. All right. Let's put the cap on this problem. H's, I got 18 H's, I see 1 H here, I see 3 H's here, that's 4 H's, I see 2 times 5, 10 H's here, that's 14 H's so far. Again, 1 from here, 3 from here, 4 to 14 H's. Okay, great, I know I need 18 H's, so I'm 4 short. Okay, so from this H2 molecule, that's only giving me 16, right? So I know I need 4 more, so I'm going to put a 2 in front of here. 2 times 2 is 4, so I need 2 times that. Alright, and so just to make sure, let me recount. I've got 1 H, plus the 3 H's here, 4 H's, plus 2 times 4, that's 10, 2 times 5, that's 10, that's 14 H's, plus the 4 H's here, that's 18 H's. That checks out, and my equation is balanced.